Hi, my name is Claire Hefner, and our topic is on streams. What is a stream? A stream is a body of water that flows over land surface. It can be large or small in size. Rivers, on the other hand, are the larger major parts of the stream system. Rivers and streams are often used interchangeably, but just know that the rivers are the larger parts of the stream. Rivers have three parts: the valley, the channel, and the floodplain. The valley is the sloping part that lies on both sides of the stream. Valleys are often in between hills or mountains. Valleys caused by streams are mostly V-shaped, but they can also be broader. And valleys located in high mountains are narrow with steep sides. Channels. Channels are located at the bottom of the valley and carry water during non-flood times. When water levels are low, the stream runs at the bottom of the channel. When water levels are high, on the other hand, the stream fills up and occupies a majority of the channel. Here we have two pictures of meandering streams. The floodplain is the flat area within the valley located on either side of the channel. The floodplain is the part of the valley that gets flooded during flood times when the stream overflows. When the stream spills over, it spreads out over the floodplain and quickly loses velocity and carries with it silt and sand from the channel. The sediment is then deposited along the intermediate borders, forming natural levees. Natural levees are made of natural coarse materials that keep the stream within its natural banks when it floods. Floodplains have fine grained sediment layers, which leads to good soil. Here we have a few pictures of floodplains.
Alrighty, I'm Wesley Goodman, and our project was on streams, and this here is meandering streams. Meandering streams are single channels that have bends and curves, low velocity, and usually low sediment load. They feature things like cut banks, point bars, and oxbourne lakes. Uh, Meandering streams are faster on the outside than the inside. There's a few pictures there and graphs for you. And then we also have things like cut banks. Now, cut banks are areas that experience a great amount of erosion due to the streams themselves. They're located on the meander or the curve of the stream, and the streams usually move faster. We also have point bars. Point bars are located on the inside of the meanders. Water is slower here, and the sediment eroded on the banks is usually deposited here. You can see the sand and whatnot over time of the stream moving itself. Oxbourne lakes are the U-shaped bends, as you can see as it goes through here. Uh, and slowly that stream will detach and it will form a small lake. The water itself is still because the water is not continuously moving through it, but eventually the water will subside. It will dry up because that water is not there, and it will become either dry or even a swamp.
Hi, my name is Abigail Ramsey, and I'm going to be talking about streams, more specifically, braided streams and stream drainage. Braided streams are streams that have many channels that interlace together just like braided hair. These streams are separated by something called braid bars. Braid bars are areas of collected sediment that serve as divides within the stream. Braided streams are usually found high up in the landscapes. They have high sediment loads that easily erode banks, and they often have swift flowing currents. Here are a few aerial images of braided streams, and you can see the difference between the streams themselves and the braid bars that separate and intertwine them. Another important part of streams is stream drainage, and there are four main kinds: dendritic, rectangular, trellis, and radial. Dendritic drainage is characterized by its looks, and it looks like the end of a tree limb. Rectangular drainage has strong joints and is usually found in rocky areas. Trellis drainage is found in valleys and ridges near more weather-resistant rocks and looks like a trellis on the outside of a house. Radial drainage is flowing downhill from either mountains or volcanoes. Here are some images of the different kinds, and you can see the differences. Here's a more up-close picture of dendritic drainage, and you can see its resemblance to a tree limb. These streams form from almost anywhere, unlike other streams mentioned, and they do not have a set location. Rectangular drainage forms around strongly jointed rocky terrain featuring sharp turning bends. The stream itself appears to turn at a rounded off right angle, thus the title, rectangular.
Hi, I'm Elizabeth. A trellis river pattern is usually found in rocky areas like ridges and valleys. It develops in folded topography and often includes synclines or anticlines. Radial streams form from currents moving downstreams from a high point, such as a mountain or a volcano. Water has two currents, laminar or turbulent. Laminar, which is parallel and moves gently and in a more uniform way, and turbulent, which is chaotic and goes in multiple different directions. Depending on which current flow the water has, affects things like erosion and also the size and type of sediment that it carries.
Hi, I'm Mariah, and today I'm going to be finishing this presentation off for you guys, but I still have a couple topics that deal with streams to talk about. And the first one are currents and levees. As the water flows and water levels rise and fall in floodplains, over time this is just going to push the sediment towards the side of the flow, creating a natural wall around the outside of the stream, as we know are levees. And this picture is a great example of us just being able to see the actual wall formation around the stream. And levees are formed by the river depositing coarse silt and sediment when it floods. Next, I'm going to be talking about drainage divides. Another byproduct of current drainage is the creation of drainage divides. These can vary in all sorts of sizes, but they can be just as big as mountains, some of them. As water flows, it creates a depression which slowly grows until in some cases the divide creates vast valleys with mountains dividing them. So drainage divides occur in raised areas and terrains such as mountain ranges or hills. Basically, a drainage divide separates streams flowing into one drainage basin from streams flowing into another. If precipitation happened on one side of the drainage divide, it would go straight into that drainage basin and not the other, whereas if it happened on the other side, it would go into that one. And this picture is a great example of that. And deltas are the next topic. Deltas are deposits of sediments, and they form near river mouths, and they're formed when slower moving streams deposit sediment on its way to a bigger body of water, and it's going to leave a triangular landform. And the bigger bodies of water that the sediment could be deposited into could be various, such as the ocean, sea, deserts, or it could be another river or a lake. It could be a bunch of big bodies of water. And it does leave a triangular landform, but deltas often tend to have different shapes depending on how much sediment is being deposited into them. And a couple examples of deltas are the Nile Delta and the Mississippi Delta. And here are some images of deltas, and this will just also give you a good idea about how they don't always have the exact same shape, and it really does just depend on how much sediment is being deposited into them. Next, I'm going to be talking about alluvial fans. An alluvial fan is a fan-shaped mass of alluvium deposited as the flow of a river slows velocity. And the name fan really does describe it well because it does end up having a fan shape, which you can see in this picture example over here. A fan-shaped mass of sediment, especially silt, sand, gravel, and boulders, deposited by a river when its flow slowed. How are alluvial fans formed? They're formed by slowing streams depositing sediments along the edge of the current. And the shape of the fan is related to the grain size. So just an example of this would be fans built of silt, sand, and fine gravel. They're going to have a more broad, flattened profile than if they were bigger boulders and stuff like that. some more on alluvial fans to help you better understand what they are. So where they can be found. They are often found in deserts where flash floods have washed alluvium down from close hills. And they're also found where streams are located a lot of times when it's wet. It makes it easier for them to form. And they're typically found at the exit of a canyon onto a flatter plain, and they form in areas where there is sudden change in landscape. It makes them a lot easier to form. And the sediments in an alluvial fan tend to be coarse and poorly sorted materials at the head of the fan, whereas if you go farther out in the fan, it's more likely that you'll find sandier sediments down there. Maybe they're still going to be poorly sorted, but they'll be more sandy. And I'm going to go back just so you can get a better idea and just look at this picture a little more. It really does fan out into an exact fan shape, which makes it very easy to remember alluvial fans. And this is all I have for you guys today. And I think this also finishes our PowerPoint, so thank you guys so much.